Hello friends, let us see one more example. Trace the curve ay square equal to x square into a minus x square. We write the equation as a square y square equal to a square x square minus x raised to 4. Now first rule to check the symmetry. So for that we need to check the powers. So if we observe here in this equation, both x as well as y has even powers. And since both x and y has even powers, we say the curve will be symmetrical to both x and y axis. Also, if you observe, if we replace x by minus x and y by minus y, we get back the same equation. That is a square y square equal to x square into a square minus x square. So that means we can also say this curve will be symmetrical in opposite quadrants. So here two conditions of symmetry are satisfied. One, it will be symmetrical to both x and y axis. Second, it will be symmetrical in both opposite quadrants. Next, we need to check whether the curve passes through origin. So substitute x equal to 0. We obtain y square equal to 0, that means y equal to 0, therefore we can say curve passes through origin. Also y square equal to 0 tells us that the curve, this point is a double point, so we need to check the nature of this double point. So we find the tangents by equating the lowest degree term to 0. So here lowest degree terms are two terms, a square y square and a square x square. So equating these both terms to 0, we get the equation as y square minus x square equal to 0, that is y equal to plus or minus x. That means we get two equations, y equal to x, y equal to minus x, which are tangents at origin. So these are the two tangents at origin, y equal to x, y equal to minus x. So next we check whether this point where the curve passing, since these are two distinct tangents, this point will be a node. Next we check few more points of intersections. So for that, substitute y equal to 0. We get the equation of as x square into a square minus x square equal to 0. That means x equal to 0 and a square minus x square equal to 0 means x equal to 0 and x equal to plus or minus a. So we get 2 points, two more points here. One we know that is origin. Next a 0 and minus a comma 0, which are the points of intersection with positive x-axis and negative x-axis. So suppose this is a comma 0 and here it is minus a comma 0. Okay, again if we observe, there is no particular coefficient and here which we can equate to 0 to find a asymptote. So we can say there exists no asymptote here. Next we need to check whether the curve, the region of absence of curve, where the curve does not lie. So if you substitute now here x is equal to positive term, some value greater than a. Suppose we substitute x equal to 2a. So we get the equation as a square y square equal to x square 2a, so this is going to be 2a square into a square minus 2a square, right? So this will become 4a square into a square minus 4a square, means obviously this term is going to be a negative term. So negative term, that means y will be negative, y will be imaginary. So obviously curve will not exist beyond x equal to a. Now if we substitute similarly some value x less than minus a, suppose we substitute minus 2a. So again minus 2a means this will become a square y square equal to minus 2a square into a square minus of minus 2a square. So we observe we get the term similarly a square minus 4a square. So obviously this a square minus 4a square will be minus 3a square, means y square will be a negative term, that means y will become imaginary for all the points beyond this minus a. So curve will not exist for x greater than a and for x less than a. So till now we know curve is passing through origin. There are the two tangents like y equal to x, y equal to minus x. The curve will cut or intersect at point a comma 0, minus a comma 0. Also we know now the symmetry is, it is with respect to x-axis as well as with respect in opposite quadrants. So the first we can say there will exist a loop in between 0 to a. Also there will exist a loop between 0 to minus a. If you want, you can check values at a by 2 or minus a by 2 and check how y varies. Suppose I substitute equal to minus a equal to a by 2 in the equation. So this become x equal to a by 2 in the equation. This become a square y square equal to a square by 4 into a square minus a square by 2. Means this becomes a raised to 4 upon 8. Means I can write y square is equal to a square by 8. Means where I obtain y is equal to plus or minus two values a by root 8. Means y varies for a by 2. Similarly, obviously y will vary for minus a by 2, and hence the curve will pass like this. So there will exist a loop between 0 to a and 0 to minus a. So if you observe, the curve is symmetrical to x-axis, symmetrical to y-axis. It is also symmetrical in opposite quadrants.